The European Auto ID Centre at Cambridge University is building a laboratory environment that can be used to demonstrate the benefits of Auto ID technology in manufacturing. In this short video, we are going to show the advantages of this Auto ID based control in the first of 3 phases of ongoing development of our automation laboratory. We are going to demonstrate the packing of Gillette gift boxes. We have 4 different types of Gillette product, namely razors, deodorant, foam and shaving gel, that can be packed into 2 different styles of gift box using a pick-and-place robotic system. This is a plan view of the robotic packaging cell. In the centre is the robot arm, on the right-hand side there is a conveyor system that delivers items, and a similar conveyor on the left delivers empty gift boxes. This is a picture of the real robotic cell. We can see the incoming goods, the final product, we can see the locations of the tag readers, and at the back there's a storage system. In the middle is the robot itself. To demonstrate the operation of the cell, we will present a number of different scenarios. In the first scenario, goods arrive on the incoming conveyor in an unpredictable manner. We don't know in advance what items will arrive at what times. However, because they are tagged, as they arrive, they are detected and identified by their electronic product codes, or EPCs, and the robot knows where to put them in the mini warehouse. Razors, such as this one for example, belong on the leftmost side of the warehouse. Note that all the items in this demonstration are held in uniform white plastic item carriers. This is simply done to make it easier to pick them up. More products will now arrive on the conveyor. Again, the EPCs of the products are detected as they arrive, and so the system knows that they are cans of shaving gel, which belong in the rightmost side of the warehouse. As you can see, when everything is running smoothly, products will always be in their expected locations in the warehouse because the robot always puts things in the right place. Of course, in real life, things don't always run smoothly. The next scenario shows how the Auto ID information detected within the cell can be used to recover from unexpected conditions. 2 operators are going to simulate a human error by moving an item into the wrong location in the warehouse. In this case, a razor is placed amongst the foams, although the system can actually detect and deal with any combination of errors. Following the modification, the warehouse is put back into operation. As soon as this happens, the RFID readers in the cell detect the error and command the robot to remove the offending razor from amongst the foams and put it back to the left-hand end where it belongs. The third scenario shows an empty gift box being packed. Initially, the robot starts to unload items that arrive on the right-hand conveyor. The first of these items, a razor, is placed into the warehouse. Of course, the system knows that it's a razor because of the EPC, which is red when the item enters the cell. However, unloading incoming goods is only a second priority for the packaging cell. The highest priority is to pack gift boxes. Therefore, when an empty gift box arrives on the left-hand side of the cell, the second razor is packed directly into it. Now that the first shuttle of items has been unpacked, it moves on its way on the conveyor, and 2 more items arrive. However, the highest priority remains packing the empty gift box, and so the packing is completed next, using a gel and a deodorant. It's important to realize that the contents of each gift box that is to be packed are specified individually. The system uses the EPC of the empty gift box to find out, from a networked PML server, what should be packed into that specific box. In other words, we can readily carry out mass customization of products. A new gift box and new items enter the packaging cell. Once again, the highest priority is to pack the empty box, but if this can be combined with unloading items, so much the better. This time, however, the gift box is a different physical configuration. The items have to be placed in it in different orientations within the box. The system knows the configuration of the box because of its EPC, and again the packing list for this box is stored on the PML server. This time, one gel is taken from the goods in conveyor, one deodorant and one foam from the warehouse to make up the gift box. The penultimate scenario demonstrated in this video shows how the customization of products can actually be carried out at a very late stage. To understand how this works, let's look at a special human interface we have developed to show what's happening under the hood of the packaging cell controller. On the left-hand side of this interface, there is a diagram showing an empty gift box inside the blue circle. The gift box is empty because there is not yet any order associated with it. The system has not been told what items to place inside it. We can use this interface to specify what items we would like to be packed into this particular gift box. When the order has been customized in this way, the information is written to the PML server. The right-hand side of the interface shows the order information, highlighted in orange. Ultimately, when the box has been packed and the order fulfilled, the PML data will be updated to reflect this, shown here highlighted in green. The final scenario demonstrates the ability of AutoID enabled packaging system to do quality control of packed boxes before they leave the factory. As we just saw, the PML server contains information about what items should be packed into a given box, shown here in orange, along with details of the items that were actually used in green. By comparing these two sets of information just before a box leaves the factory, it is possible to detect any packaging errors or tampering. Here, the cell is just packing the final item into a gift box to complete a particular order. As the completed box leaves the packing station, it moves along the conveyor and through a quality control station. The RFID readers in the quality control station check the contents of the box, and a red or green light can be flashed as appropriate. The technology behind the scenarios presented in the last few minutes obviously applies much more widely than simply enhanced packaging of Gillette gift boxes. There are many different applications from manufacturing operations to distribution, which can benefit from using AutoID information for control. The work at the Cambridge AutoID Centre to design and build AutoID-enabled automation systems is ongoing. We believe that this technology will one day be as pervasive as the barcode is today.